Well, it's Tuesday, April the 6th, and you're in the know with Nadine and Chris. And Nadine, we're talking about a subject here where a lot of Canadians, well, a lot of people around the world are probably excited to do once again one day, and that's travel. But we're not going to be talking so much about the COVID situation, but the climate variables impacting on air travel. So you had a chance to dig into this subject a little bit. What have you been finding out?
Yeah, certainly, Chris. We're all hoping for eventually when life gets back to normal and we can see the world again. Well, a recent study by Professor Paul Williams of Reading University in the UK revealed that overall travel times to transatlantic and trans-Pacific times are longer in these phases. So I had a chance to speak with him, and this is what he had to say.
In winters, when the North Atlantic jet stream is persistently strong. So, for the entire 3-month period, December, January and February, the North Atlantic jet stream blowing stronger than average. So this is the positive part of the North Atlantic oscillation. We found that an eastbound flight from North America to Europe would be 19 minutes shorter on average, and that's because of those tailwinds. And conversely, westbound flights from Europe back over to North America were 23 minutes longer than normal because of the headwinds. And it's a similar story in the Pacific in winter, when the Northeast Pacific jet stream is stronger than normal. So this is the positive part of the ENSO, also known as an El Nino event. We found that eastbound flights from Hawaii to the USA were 15 minutes shorter because of the tailwinds, but a westbound flight on the opposite route was 22 minutes longer.
All right, well, Nadine, the doctor mentioned a couple of terms there, so let's dive into a little bit. He's talking about the NAO, that's the North Atlantic Oscillation. And quite simply, when it's in the positive phase, it means that the low-pressure system over Iceland is quite strong, the high pressure over the Azores is quite strong, and that pressure gradient or difference enhances those westerly winds, meaning you can speed up travel from North America to Europe. Now, we also mentioned about the positive phase of ENSO, which is actually La Nina, but that does increase the trade winds, the upper level winds, and that also can have an impact on travel. So really, the net effect, Nadine, are we gaining time or are we losing time on our flights?
Well, surprisingly, you'd think that with shorter eastbound flights, they would be canceled out to zero with westbound flights. But it actually turns out that the slowest part of the journey actually slows down the overall flight times. So your overall flight time is actually longer. And there are a couple of impacts to that.
And there are two consequences there. One is the extra cost that it's going to take the airline to buy that fuel. And we calculated sort of tens of millions of extra dollars. And the second consequence is, of course, that it puts more emissions into the atmosphere.
Right.
And certainly, Professor Williams is hoping that in time with more research and greater planning, the aviation industry will be able to plan for these impacts and these consequences and these additional costs that will ultimately be passed down to the consumer, Chris.
Well, let's talk about some of the drivers that are impacting the weather here at home this week. And we've got a blocking pattern here, an omega block. You've got low pressure on either side of high pressure. And if you're in Atlantic Canada, this means rain, this means drizzle, this means fog, and this generally means cooler temperatures for a lot of places because of that persistent onshore flow.
Yeah, meanwhile, for us, as we head back across the west, we've got that trough that will be sliding in on the west coast, pushing into the prairies. And you'll notice how it drags that low from northern Ontario up into that trough, Chris. So unsettled conditions there as well.
And big temperature swings to the shores of James Bay, 20 degrees above normal. Meanwhile, you get up towards the Yukon and Alaska, 20 degrees below normal. Now you're in the know.